Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 47 of chapter 4 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.J. Craig, and J.N. Bolton. Statement of the problem is determine the force in member CG of the loaded truss. So the four external reactions at A, B, E, and F are equal in magnitude and are directed perpendicular to the local supporting surfaces. So the reactions are perpendicular equal and they are perpendicular to these surfaces. So as force in only one member is required, so I'm going to solve this problem using method of section. So these are steps to find member forces using method of section. The first step is need to plan a cut that pass through the target member. So target member is CG. So need to that is a cut, and then that cut is passing through the target member CG, and then at the cut there must be three or less unknown forces. So there are three forces CD, CG, and GH on the cut, and then need to choose simpler side of the cut. So at the cut, the truss is being divided into two sections, right section and then left section. So right and left section both are identical, so any part can be selected. So then at the cut, there are at each cut there are two reaction forces which are not known. So need to find reactions first. The steps to find reaction in truss is the first step is need to draw free body diagram of entire truss by ignoring internal member and replacing supports with reaction. So in A and B are pin support and E and F are roller supports, but in the question statement it is described that the reactions are only perpendicular to the surfaces. So free body diagram of truss is drawn. So there are two known loads, and then at each support reactions are is the same. So at A it is RA, at B is RB, then at E is RE, and then F is RF. So all these reactions are same, and then these reactions makes an angle 45 with the horizontal, because the angle here, the angle is 45, so that angle is 45. So then all reaction that makes angle 45 with horizontal. So next need to apply equilibrium condition to the whole truss. So applying sigma m equal to 0, sigma fx equal to 0, and sigma fy equal to 0. So all reactions, they are resolved into their vertical components RAY, RBY, RFY, and REY, because the known loads are in vertical direction. And then applying sigma Fy equal to 0. So RAY, RBY, RFY, and REY, they are acting vertically upwards, so they are positive, and both of the loads are acting vertically downwards, so they are negative. And then all reactions are same, so then all they are being replaced with R reaction RY. So RY plus RY plus RY. So all 4 RY is equal to 2L. So 4 RY is equal to 2L, and RY is equal to RA sine 45. So 4R sine 45 is equal to 2L. So reaction is equal to 1 over 2L. So because the answer is positive, a positive value confirm assumed direction. So now the chosen direction of reactions is correct. So once reactions are found and then I'm going to choose a simpler side of, so both are same side, so then it is possible to select any, because both are the same side, same number of joints and same number of loads and reactions. So I'm going to select here left side for analysis. So, and then when truss have curved member, so in a pin joint truss, a curved member behave as two force member. So its effect is same as straight member. So therefore, it transmit only axial force, and that is a tangent to the curve at a joint. So CD is a curved member. So CD is a curved member, so it will behave as a straight member. Then HG is again a curved member, so it will behave as a straight member. So here is left section, and on the left section, CD and CG, instead they are curved, so they are selected as straight members. And then CG is other members. So CD and GH are now horizontal. So then need to analyze this section. So for this section, to analyze, equilibrium conditions are used. So I have already assumed unknown cut member in tension, then need to apply conditions of equilibrium, and need to resolve inclined member into their components. So three conditions are available: sigma m equal to 0, sigma fx equal to 0, and sigma fy equal to 0. So there is one inclined member CG and need to resolve into its component. And CG makes an angle theta with horizontal, and first need to find that angle theta. So to find angle theta, the center of radius of curvature, so that is a curvature, so its center is assumed as origin with 0 0 coordinate, and then the radius is given, and using radius and angle it is possible to find coordinates of C and then coordinates of G. So I have drawn a triangle from O to C, and that is the right triangle, and in that triangle its hypotenuse is R, so and angle is 15. So using hypotenuse and angle 15, it is possible to find what is the adjacent side and what is the opposite side. So the opposite and adjacent are used to find coordinates of C. So in this triangle, OC, that is hypotenuse, angle is 15, and OC is opposite side. So using sine 15 as opposite over hypotenuse, it is possible to find O dash C. And then similarly, using angle theta, it is possible to find O dash using cosine 15, which is adjacent over hypotenuse. So now for this triangle, its one side is R cos 15, or vertical side is R cos 15, and its horizontal is R sine 15. So then the coordinate of point CR, so its coordinate is R cos 15, and its x coordinate, because that is the origin line considered, so that is minus R sine 15. So the coordinate of CR minus R sine 15 and then R cos 15. So the other coordinates of the point I need to calculate are G. So the radius of G is 3/4 R, and its angle is 15. So the coordinates of G are positive 0.75 r sine 15 and 0.75 r cosine 15. So now using the coordinate of C and G, it is possible to find its gradient. So using basic geometry, it is possible to find its gradient, and gradient is change in y over change in x. So the gradient m of CG is change in y over change in x. So that is 0.75 r cosine 15 minus r cosine 15, and then 0.75 r sine 15 minus r sine 15. So that will become plus. And then by taking r as common factor and then simplifying, so it is minus 2 minus root 3 over 7. So now using the fact that gradient is equal to tan theta, so then tan theta will become minus 2 minus root 3 over 7, and then theta is equal to tan inverse of minus 2 minus root 3 over 7. Now the theta is minus 28.06, and this theta negative represent that this angle is below x-axis. So just ignoring the sign, negative sign, so theta is 28.06. So after finding theta, it is possible to resolve inclined member into its components. So one of the inclined member is CG. So it is resolved into its components CGX and CGY. And similarly, reactions, so they are resolved into their component as RBX, RBY, and RAX and RAY. And both reactions are same and they are equal to 1 over root 2L. I need to find CG. So there is only one unknown in vertical direction. So I'll apply here sigma Fy equal to 0 to find CG. So now sigma Fy equal to 0. So then CGY is negative. Then RBY is positive vertically upward. Then RAY is positive as is vertically upward, and load is acting downward. So that is minus equal to 0. So RB and RAY, so they are, then CGY is written as RBY plus RAY minus L. So RBY is RB 1 over root 2L sine 45, and the other one RAY is 1 over root 2L sine 45. So then substituting the values of theta, because theta is calculated as 28.06, and then simplifying. So right hand side, that will become equal to 0. So 0 divided by sine 28.06 is 0. So member force in CG is calculated as 0. And that is the answer. So thank you very much for watching.